Good evening and welcome back to Evening Rust. I'm edA-qa mort-ora-y, and this is my show where I learn Rust and compete on the game's uncoding game. I managed to get a little bit early start today, not very much. I'm sorry about that. I'd really love to start a bit earlier, but just when the time comes up is at 11, unfortunately. But we're going to continue anyways. We're going to see how long we go, and we're back to Clash of Code. Yesterday we started doing some sort of challenge where little cars run around and collect water. We're going to keep doing that today. Yesterday we made some good progress without much thought, and today we're going to probably do some more of that. Before we start, I think we're going to try and join one of these clashes, see how poorly we do on this today. If we get another golf one, that's for sure we'll lose, and pretty much we'll lose in the other one as well, but I thought it's just a good way to get started, and we'll see what happens here. Maybe I should put the little notice again. Just say we're live again. Why not? We'll just do it here. It's in the notes here. See what happens. I don't know any of these guys. This might be entirely new for us. And I'm probably going to fail. Let's see, one more. And please just... I've never had the reverse engineering one. I'd love to have the reverse engineering one today. That'd be something fun to do. And, we got all of them now in 5 seconds. Because the speed one, I haven't warmed up yet, so there's no speed. So really, only the reverse engineering would be good for me. Shortest mode. Lowest code set, so we're guaranteed to lose using Rust. But let's see how well we can do. Check if a positive number n is happy or not. A number is called happy when repeatedly summing the square of its digits yields 1. For example, if n equals 86, its digits are 8 and 6, and then 8 squared is 64, 6, 100. 100 to 100 equals 1. Therefore, 86 is happy. That's got to be the strangest code I've seen before, but we're going to need a mod operator. So we have some digits, we have this, we need to parse input. This is the code, this is what kills us in the Rust. This is all this input. We can already get rid of the print error. We'll get rid of print error afterwards. We don't need the auto-generate code. That always cuts some code off size here. We can get rid of this, get rid of the answer. But this is going to kill us a lot. And so now we need to loop while we still have a number. And repeatedly summing the square of its digits. I don't know. I'm not sure. It's really weird. I wonder if there's an end condition. How does it end? How do we know if it otherwise ends? Does it end up as 0? Must end up as 0 at some point. So let's do this while n is greater than 1. I don't think we have a loop there for that. And we're going to say, we'll do this. If n equals 1, then what do we output? Happy, else unhappy. And that's going to cost us a lot right there. I'm just going to try and focus on finishing first, so is whatever n. And so we're going to count the new number up, and I'm going to say let mut q equals n, and we'll say while q is greater than 0, let mut o equal 0. We'll start at 0. We're going to add the numbers up. Now, how do we get the lowest number from this? Let's hope there's a mod operator here. Let digit equal q.mod 10. I hope it's here in that. So O plus equals digit times digit because it's squared. And O Q equals Q divided by equals 10. I hope that floors it down. And we're going to keep going, and then we say n equals O, the new value we added up. And let's see what happens with that. Modulus. Okay, so we're going to have to look this up. We're going to lose some time here for Rust. Modulus Rust modulus. I don't know how to spell that actually. Modulus. As far as I can tell, there's no modular arithmetic function. Oh god. What does that mean? I don't get it. I don't understand what it's saying, so let's just do percentage 10. It looked like that might do something. Found happy. We get rid of the n. There's no then, but there's an else. Macron definition. Mutable area n19. We'll just make that mutable. Those are going to cost us time too. Found one is happy. Oh, that was stupid. We should have left it not mutable. Let O equal n and just do O here. Oh, we'll get rid of O here. And then we'll say O equals 0 again. Reset that. Come on, we're doing badly here. And we don't need to do the O there. We have an O. Okay, so now I'm trying to figure out why is this happening here? What do we have here? Not print line. We might actually fail time-wise. That'd be pretty embarrassing, huh? What does O look like here? (32, 32). So we got a loop here. This is what I was wondering about a loop. This really sucks if it's a loop, and it means it's never going to add up to 1. So I don't know. 32 is 9. 32 should be 9 plus should be 11 though. Q equals n. O equals. Well, this is really weird. That should have been Q. Let's see what we have here with Q. So we start with 404, we get down to 32, and we start 44. Oh, we keep saying n. That was pretty stupid of me. Alright, so let's get rid of these print lines. Okay, try that again. And this should be O. If O, whatever the resulting number there is. Okay, let's be capital is. Let's see if they all work, or we failed. Alright, we'll check the test case. We're actually going to fail this one. We don't have enough. 69 is unhappy. Let's see what we have here. So each time we go through the loop, we're going to print the line out. Or we're going to print the error out. Start with O. And then we'll print what we get for Q each time. Goes to whatever Q comma O. We're going to figure out what this is doing. Print error meant that. 10 minutes is kind of short. There's something with the numbers here I don't quite get. 69 goes to 0, 6 goes to 81. Let's do this afterwards. Let's do this again so I get the better number. So 69 goes to 81, that's correct. 81 plus 36, that looks correct. 117 goes to 49, 50, 51. 51 goes to 1 to 26. 26, 36, 40, 40, 0, 16, 16, 19. And, okay, this is what I mean. Repeatedly summing the square of its digits yields 1. They don't give us a terminal case. What am I supposed to do if it goes into a loop? What if it's not even a loop? What if it's just keep random numbers? I can't keep a loop for this. These numbers aren't repeating. I'm actually stuck for the algorithm. What I should actually do here. The constraint is I'm really not seeing how. What do we have comments here? When you hit 1, you won't leave. Yeah, repeatedly. I don't know if this is other end. Okay, it's going to keep going up. I don't know what I actually don't understand what the question is, because this could loop for a very long time. There's 100 numbers here, and yeah, we have a number. Okay, we can do that. So let's do a set. Let's do that then. Let's check if the number's already there. Rest, there must be a set. This is going to take a while. Rust set. No, we're not going to get time. We're going to run out of this. We have a hash set. Let's just see if we can do this quickly. I just want to get it done. We're running out of time here. Let mook all dot whatever we do, insert n. If all dot, how do we say find, contains, all dot contains n, we're just going to print line it's unhappy and finish this off. It is unhappy. Oh. M return. Okay, if we don't need that. Good run at a time though. Okay, come on, come on. What do I have to include for set? Use standard collections has set, which is costing us even more stuff. Try this again. Expected I32. This is really annoying. I shouldn't need to borrow that. Whatever. .404 is unhappy. 432. If all contains not and. Oh, stupid me. Oh well. Should probably insert it as well. All dot insert O. Okay. Let's play them all. Oh no, we have an unwrapping trace there, that's bad. Where do we do this at? 20, line 20. Well, this is mean. This is really stupid mean. I mean, this is their code again. I didn't emit this code. That's their code. Yeah, this is, I can't fix this fast enough because this would actually have to be a string then. And I can't fix this fast enough in Rust to go to a string. We actually need to do a string. And what would this actually be? And I can't fix it fast enough. I'm sorry, there's no way I'm going to be able to do that fast enough. Let's just submit it. There's nothing I can do. Coding game, emitted code, parse value incorrectly. Threw me off. Big test fails parse. So we're just going to have to skip that. There's nothing I can do. I mean, if I knew it was a string at first, I was actually thinking of doing that. We would have done it a different way, but I didn't have enough time with the hash set and everything to actually recalculate my loop to actually do that correctly. Alright, so let's just move on for now. We're going to submit it. And bad Rust parsing to expect an I32 when a string is required. The Rust code template parses an I32. This was it. It was okay, kind of fun. Difficulty. I think this was actually, well, these are not clear enough. I'm going to say test cases are bad because of that. Should we try another one? There's no one here. Let's just try another one. Let's play again. Flash is also... I don't know what that is. Alright. So I can't do much about that. I was thinking about a string, but you know, when the code template comes out and says parse an integer, you kind of have to expect that it's going to be an integer. And if it can't parse an integer, and you're getting errors and that's not even my code, I can't fix it fast enough. It wouldn't be so hard to fix the thing using strings before, assuming the numbers don't add up to more than an I64, but we didn't do that, so we'll have to see. We'll just see what the next test is. This will be the last one, then we'll move on back to the compete section again. We'll go back to the code we had yesterday, and we'll see what it does. We have the same people again, and as long as it's not a speed one, only Rust stuff I know. We were ranked 5. I don't know. Ranked 5. I mean, we failed. Nothing to do with code size. But we get points for that. That's totally fine. I have something to say. Whatever. Like. And that's okay, we get points. We're getting fun, we're learning. We learned a hash set. Look, that was new. Oh, you didn't know what a hash set was before. Now we knew a hash set. I'm never going to remember the use. Standard collection has hash set, hash set. I don't actually like hash sets, but I had a sense that they'd actually have one because everybody has hash sets, even though they're very bad form or general storage. So I'm going to have to justify that one point, but trust me on that. And since everybody has them, I know I can look it up as fast as possible. Who cares? Maybe you have C candles. The candle has finished to burn. It remains generally a bit of it, and when E candle ends, you can make one candle survive longer. How many candles are you going to burn until you don't have enough ends of them to make another? C candles. With E candle ends. The number of candles at the beginning, the number of E ends needs to make a candle. The total number of candles that you'll be able to burn or impossible if the cycle is infinite. And cycle is infinite, okay. So each one has a candle end. How is this just not an answer here? So we're going to say while, let's say mut C. C is greater than 0. Let mut total equals 0, I32. Total plus equals C, we burn that many candles. C equals, we're going to have a bits equals 0, I32, we need some bits. And we're going to say bits plus equals C divided by E. No, we say bits is C, okay? And then we're going to put C back equal to bits divided by E. And then bits equals bits mod E. So there's some left over each time. And let's see if this was actually quick enough, the answer I got. And the total should be this total. Pile errors, of course. Attempt to divide by 0. Okay, bits plus equals C, otherwise C. I'm going to do a case section E equals 0. Print line impossible. And goes forever, and then return. 42. Oh no, now we're in a shitty debugging mode. Now we're going to have a problem here. What are our values? C, comma E. What are our values? C, comma E. Now we're losing time. 42 and 0. We should have found 42. Well, that's not fair. 0 means don't produce usable ends. Okay, fine. If C equals E, then we just print line C. Then we're done with that. Then we have to have the case where E equals 1. If E equals 1, we only need 1 bit to produce a candle. Then it goes forever. Then it's going to be impossible. Turn. Alright, let's do this. Oh, come on! Somebody was faster than me. Okay, we just got the one thing wrong. We should write a bit clearer. But I'm actually okay with that. And I thought this I could I'll share my code, I don't care. So that one wasn't so bad. Was that one fun? Actually, that one was fun. That was fun. I don't know if it was exciting. Difficulty, I think this is perfect for such things. Statements seem clear. Test case relevancy. I think it probably covered it. We never actually checked if it covered the one case. We'll just assume it did. Just submit that. And we'll see what the other people come back with. We can let this code up in time. Again, if you're just joining this, I'm edA-qa. We're playing on coding game here in Rust, and I don't really know Rust yet, and this is my chance to learn it. And I do in my own language called Leaf, and I'm trying to learn the features of Rust to see if it helps. I just try because I know it has some other features, and I want to see how I can work them into my own language. Oh, and I just noticed it's 2 seconds. A 2-second difference. That's brutal. Come on. At least we don't have to worry about code size in these ones, and it should be okay. Let's see what his code looks like. E is greater than or equals 0 and E is less than or equal to 1. Print parse 0 or 1. Okay, so he had an extra condition here. He didn't bother removing it. He's saving time. So he probably had this first, just like we did, and then he jammed this in here right away to print C instead. And parseInt doesn't. Is that an actual JavaScript function? And readline. Warnings too. Okay, whatever. That's his looks very tightly, and we did about the same, but he's actually got. I'm not sure this is the same loop. I think we handled more cases than they did. So I don't know if the test cases actually covered one of the ones we covered when we had leftover bits. We seem to be doing well this time. Let's go off to compete for now, and we'll come back later and see how we did with that. And where we were in compete yesterday was we were on this mean max one. And what do you mean join? We're already in join. Oh, we're in the bronze league. That's where we got yesterday. And how were we 175th and 377 in the bronze league? That's pretty weird. Can we possibly be made in here already? Does it auto-submit our stuff? It does. Okay, so we know where we are anyways. So we're already in the bronze league at 176, and we haven't improved our code yet. But that means we're better than a lot of the other ones already there. I'm going to have to improve this a little bit though. Obviously we need to get a little higher, but probably not a lot higher, because I think these are just rankings wins to losses. So at the top you just need to get quite high. But nobody's up above the Crazy Max, the boss, at the moment, which is good. So there must be a gold league. So we're going to have to play with this. Do we have new rules? We have new rules, but we don't care about them right now. We just want to fix our existing rules. So we're going to pop this out to be a bigger screen. And we're going to start cleaning up the code a little bit. What do they say we want to do? We don't need this. We're going to remove that comment. We have these distance functions, state definition. We don't have a state. We're going to cram this all into a state now. And that gives us a better control over it. And I'm wondering if we have to do all of these units. We generally take them separately. Do we need to do them separately? It's hard to say. We just stick them all in one. We might as well separate them out. Let's just get the exact same structure first. Or we can just say all the Reapers are on one, and the first Reaper is always ours, but that gets confusing, so we're going to say our Reaper. We'll take it exactly as we had before. Our Reaper is a unit. Our Destroyer is a unit. Our Doof is a unit. And these are all tankers, because they have no actual owner. Vec unit. And we have all Rex. They have no owners. They are Vec unit. And we have enemy Reapers. Enemy Reapers. This is going to be a Vec unit. This is the ones I'm adding now. Enemy Reapers, and we need enemy Destroyers. We're going to add the ones missing. Enemy Destroyers, Vec unit. Enemy Deuce, Vec unit. And we'll keep this state. It's a mutable state. And I wonder if we can make these global. I'm going to find out in a bit. Let's make a default for this stuff. Let's just do everything. Let's just copy it all. Let mut state equals state definition new. Get rid of all this. Mut time, we're going to leave it into there. I'd probably move it to the state. Let's leave it here for now. And in the loop, we want to have an implement state. We want to have a, let's have a read function. And mut self returns nothing. And we'll copy this all into here, and this just lets you keep our code a little bit cleaner. So we have this read state function, and it's really messy, but this is the code emitted by Coding Game, and I really don't care. Parsing code is just basically always messy. There's very little you can do about it. I mean, you can work a lot in it, but it's really of no interest to us whatsoever. And so we have self.reaper unit, self.our-destroyer, self.our-doof. Else if it's not equals 0, enemy reapers dot push unit. Unit player does not equal 0 again, and we're going to say if it's a unit type doof. Destroyer, actually keep the same order as before. And there's probably much clearer ways to parse this, but this is not the point of the game to do parsing. But if somebody knows how to do this clearly in Rust, that would be very helpful. Oh yeah, I would definitely take the time to do it. Destroyer. Copy this again to do this for doofs. The reason I'm separating this is because our strategy is going to be based on these other types. And these should all be self, of course. Self dot tankers. And I wish I could move this whole thing to the bottom, but we'll just live with this. And when we read it, we're going to have to do a clear on all of this stuff. So clear dot enemy reapers dot clear, because it sends us all its value every single time. Enemy destroyers, enemy deuce. And then our logic here, we're going to have to change our logic, tankers, tankers and wrecks as well. Self.rex.clear. And we don't need, we figured out that that's already correct. Circumference time, we might want to move those around. We clean these out and we do state.read. And this is our game loop, which is very simple. Closest rec, we have that function. And I'm going to probably move this to the state now. But I want to see if this compiles first. We're going to, actually no, I'm going to move this first to the state. Because these are now state functions. We can wrap a lot of this up into the state. We won't put the actual logic in the state, we're just going to put the info functions in here. So it's a good design, so our state, these functions are all going to be read-only. So we'll have secondary logic units that actually deal with doing the actual strategy. So we have a unit, closest rec to whatever unit, and I think we should be fine. Let's see, self.rex.len, self.rex. Okay, and so all of this here is going to do like state.closest rec to state.our-reaper, and this is going to fail. This better not fail me. Okay. State.rex, and we're just going to do direct access to this stuff. State.that, state.that, state. State.our-destroyer to state.our-reaper. 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 State.our-destroyer. And what do we have here somewhere? Enemy score. When we don't have the scores in here, so we need to have the scores as well. Where did I put the scores? Where is score? These lines are all packed together here. Self.enemy score dot push. Self.enemy scores dot push. And we better put the enemy scores here as well. It's the enemy scores. Enemy scores are going to be, so we probably don't need new if we have a default. Actually, let's say new and just stick a default in here. State default. Enemy scores are going to be a vector of I32. Let's hope they never get higher than that. Enemy scores is really a mess to read. Okay, they should have made nicer parsing functions. Okay, so we have two scores. We're probably going to have to read more of here. And let's say our rage is an I32. Where's our rage? Let's put our score as well. Our score. I'm wondering if these shouldn't actually be combined together because we have the exact same thing for all the enemies, and I'm undecided on that yet. We'll see what happens there if it actually is required or not. Self.our-score. Where's our rage? Self.our-rage. Okay, and what do we have? We have enemy. Just going to ignore the enemy rage for now because we don't actually use it. So let's go back down to wherever we have. Oh, we do use enemy scores. 0. That was the whole reason we went up there, wasn't it? Self.enemy reapers. 0. Self.enemy reapers 1. And we're probably going to want to borrow these things. Borrow. We don't want to take them away. Okay, and we're going to have the same thing down here. Let leader. Although this is really inefficient strategy, we're just going to do it this way for now. Time plus equals 64. And that's fine. And maybe we should do that right at the beginning of this step. We have no time. We start the time. That doesn't matter. Let's see what errors we get. And what is this anyways? Restore default code. That seems like a dangerous button to have. Let's see what errors I made. And once this compiles, I'll send out the link to say, hey, we're here. Come join us. Our rage, yeah, keep throwing that up. These are all commas. And that was all it took. That was all it took to fail. Okay, expected found. Right, the return value is slogan use this. You don't put that if you have no return value. Line 222. Do we have a way to go to line numbers? No. 222. And self. Oh, we don't need to have that. 240. My rage is not found. Self.myrage. No, state. Where did I put self? 252 I put self, so this is state. State. What else do we have? Self. So we had to see what I get more now. Either it's playing or we're doing a long compilation. No, it just failed again. These games are really slow, the feedback. I don't understand why. The other systems like the practice and stuff are really fast, the feedback. That really actually hurts in the Clash too. I wonder if like JavaScript stuff is faster and that's why some of the people choose it. Because in the Clash I'm waiting for the code to compile. I guess if I just stop making so many compilation errors, I mean so many typing errors, that'll get better in time, I guess, as we do this more. So we really want to borrow these, and unused import, I don't care. Okay, and we have an error here somewhere. So we don't use this import, let's get rid of it. We don't use print error now either, so let's get rid of it. I'm just trying to clear out these imports. These warnings. The trait copy, because Vec doesn't have a copy function. Oh, that's interesting. Well, we'll ignore it for now, but I was actually kind of relying on that. Or maybe it has only a clone. Maybe clone is enough. Because we're going to actually be duplicating this state at some point. In the advance. I don't know if we have to do it now, but in the advance we're going to be duplicating this state. 179. Enemy destroyers. State.myrage is state.ourrage. I don't know why I chose our instead of my, just that's what happened. Enemy score 252. enemy scores. And no field enemy scores, so it's probably a duplicate down here as well. Alright, let's see what happens. Let's see if we can actually get the code that was the way we had it before working. Alright, so we're actually doing stuff again. We're back to a working state. That's where we want to go right now. And copy all this code out. I'm pretty sure we probably don't beat those guys. I'm going to put it back over here into the mean max code. Save that. And let's go check on our ranking here. Okay, so now I actually have this. We have the other guys. They took a bit longer. And we got somewhere. We got some points this time. Most people managed to get 100%. That's good. Probably somebody learning Haskell. My guess is Haskell will be very good at this type of thing, but the syntax is hard. It's JavaScript, Python, Python, Python. I'm curious as to what the Python looks like. Impossible. So the same basic setup. Remaining is greater than 0. Remaining minus equals 1. Use plus equals 1. Oh, interesting. They didn't even bother using math. They just did a brute force approach. Use plus equals 1. Remaining minus equals 1. Ends plus equals 1. If ends equals e, ends equals 0. This is actually a very straightforward approach. I'm happy with that way. So no math, very straightforward. And that takes care of all the approaches with little bits, no figuring that out. And if we compare it to the IPython code, he did float. Clever too. Using float, taking advantage of its bits to take care of the end. And that looks good. And Ruby, I haven't looked in Ruby in a while. I don't actually understand the Ruby code. It looks a little bit different and should be okay. Okay, so let's go back to the coding game, compete. Let's get rid of this clash. Channels, we'll go general. Now let's actually go over to here. Where are we at compete? We're on mean max. And do we have an actual mean max channel? No, we don't. So let's just go throw our message in there and see if we can get anybody to join us. And throw an ad in here just to annoy people. Hope they enjoy the show as well. Close that off. And the German one, we don't have too much feedback. Are we still in there? Yeah. Okay, throw that in. Some people there. We'll just hide it. See what happens. Close this whole thing and go back and join. Now we have our code again. Let's check to see we actually still have our code. We've had this issue before that our code had gone away on us. And that's why I copy it out. Okay, but now we actually have the state, we have our code, and so we have to start cleaning it up. So what we need to do is somehow improve this, and I'm going to move the time into the state as well. And we have to do a step and read. Let's do it. Let's call it step read. Step read, so we can put the time in there as well. And we're going to make this an F64 just because we're going to do math with it and we prefer to have it that way. And time plus equals 1. It doesn't matter if we start at 0 or 1. We just don't care. We shouldn't have to have a time base in there. So we get rid of the time. Time is there. We don't even use the time anymore. Time. That's probably stupid. Search that way. So we don't even use the time, so it doesn't matter. So the read is here. I wonder if we can move this out of line and maybe, well, whatever. It's ugly. It's in the way. I wish we could move it somewhere else. Okay, now what do we want to do now? We want to try to improve our algorithm. The first thing we could probably do, so our rank 178 is not so good, is the movement of the Reaper. Where do we want to move a Reaper to? And we want to make a move function that calculates the optimal way to get somewhere. If we determine where we want to be, let's figure out the correct way to get there. So we're going to create a move function, emit move, and we want self. I don't know if we need that. And unit. So we probably don't even need that. We don't need to have the move, because we have this. No, we better put it in here just in case we have an optimal way later, because right now the optimal way might consider other things in this state, but for now we're just going to use it. And where do we actually want to get to? We want to get to vector... Where do we want to get to? Okay. 2. And we'll give it an and vector 2. We're going to say we want to get here. And we'll just let it emit the move directly. We could have it return it otherwise. And so far, to copy the exact thing we've had, we've been doing this. We've been saying print line and I think we just have to do like a 2.0. I'm assuming there's a floor on here. You know, it's still really weird that 0 is used as a symbol. 2.1.floor. Or maybe this should be round. Let's hope there's a round function. This is where we're heading to, because everything's in integers. It's really weird that everything's in integers. But okay, and we don't know what the throttle is. We're going to figure out the throttle. And this is why we're putting it in here. So we're going to separate out the layers of logic. And we say we want to move to the closest rec in this case. And so we're going to say emit move. So state.emit move. And what unit are we doing? Our.reaper. And state our reaper. And where are we trying to get to? We're trying to get to the rec.position. We want to get there. Now that may not be the best thing. We might want to actually take into account the unit itself. Are we trying to get to a unit? Because then if we're trying to get to a unit that's moving, we can anticipate its speed. But let's worry about that a bit later. So this is all we really need to do, and then we figure out this here. So we have the print line already. We get rid of that. And otherwise it goes to the middle. And so we want to do unit.distance to. Alright, so we have the unit.position.distance to now. And distance to 2 and 2. Man, these ands get really annoying. Okay. And there apparently is a min. We're going to look back in a second. If this compiles, we'll get back to it. So actually, yeah, we can do this. Throttle equals throttle.min distance. It's a really weird setup for that. You can't use the min function, but I'm okay with that. And we want to go to 2.1, 2.1, wherever how we get there. And this other one here we can also emit a move. State.emit move. State.our-reaper. We also want to get to that position. And we want to get to and vector 2, 0, 0. We don't care about the text for now, what they're doing. I don't think we're going to be able to debug that way anyways. Let's see if this still compiles. No, of course not. See, I wish you could get rid of this. I made a comment that I want to get rid of this because it takes up too much output. Time, so 105. Where's 105? Self.time. We call this step read now to step the time as well. And mismatched types in line 239. Emit move. Okay, what type does it want? We have no idea. Found F64 wants integer. Ugh. Stupid, stupid, stupid. Okay. I'm actually really glad I consider that fixed in Leaf. We have a 0 is a 0. It works just fine for anything you want. It's type safe even if you want to use it. Because I have a rational system in the compiler, so the rationals survive until they actually need to be a specific type. And so you don't have errors like this, but it remains totally type safe. Okay, so it works. We don't need to watch this. It's done. We just kill that there. Now the purpose of moving it to here was now what we want to do is we have this. We're trying to move here. We want to idealize this, that if we're trying to get to a position, do we really want to just point to it and do the maximum speed, or we can get there actually faster? Is there a theoretical maximum way of getting there? Because we have the current velocity. A unit has a current velocity, and what we need to do is we want to optimize that. So if we're already speeding by, you actually sometimes have to change the direction. You don't want to point to it. You might have to change the other direction. And I'm just wondering if we know actually how to do this calculation. How can we do this calculation? It's a bit of calculus to do correctly, or can we fake it here? I'd rather not fake it. So we have the velocity, and we have the time, and we want to get somewhere. And so we're actually solving simultaneous equations for an integral, because we want to know at what time, if we have this throttle and this available, how fast can we possibly get there? So how do we do that? Well, let's make an estimate function first. Let's make a function that guesses, well, where will we be in time steps? Where are we going to be in time? And I'm trying to think of how to do that. Trying to think of how to do that best. Maybe chats, no chats yet. Maybe the general one. Because if we do the time one and this way to solve it, so what I do is if we optimize this, how do I go about this? We can do a stepwise function, and we say at each step, how long will it actually take us to get there, or we just do 10 steps in the future based on that. Because we really want to stop there, and we want to optimize the time. And I'm trying to think of what's the best way to actually do that. So I'm going to just write some paper here. I wish we'd draw it. So actually, I have this drawing program. Let's see if I can actually use it. Okay, let's move this over here so you guys don't see that. So if we actually have a place we want to be, and our vehicle is here, and our vehicle is shooting off this way, and we'll let this represent velocity as well, and we want to end up here. Well, we can't just shoot this way at top speed, because what will happen is we'll end up going somewhere over here instead, and then we're going to keep correcting, we're going to spin around. Whereas we could have had an optimal approach. We could have actually instead said, Well, this is weird. I'm stuck in the drawing program. Alright, this is funny. I'm stuck in the drawing program. I can't get out of it. Okay, well, it crashed. Good, so we're out of... Okay, screw this drawing program. I'm done with it. Ardisha could go away. I've got to find a better one. If somebody has a better program, let me know. I can't deal with that one anymore. So we can idealize it. If we had that circle and we move towards it, there has to be a better approach. Because if we're already moving to the right, we don't really need to move to the right anymore. We can start moving to the left, is actually the speed we want at that time. Yeah, I'm just trying to think of how we can do this. I'm really bad at not being able to write this stuff down. I'll try to keep looking at the camera as I write some notes in the ground. I have the same basic diagram. If I'm going that way, I want to find the middle. And really, if I just go straight up, if I already have that speed, and how can I do that? So it's really, we want to optimize this somehow. Yeah, and this was a suggestion, I think, from one of the readers yesterday, or one of the chatters yesterday, is that we take the really simple approach. We just say, well, minus the unit speed. We adjust that way. It's a really, really rough calculation. So it's saying basically if we want to go to 2.x and we adjust the speed, we're already going in the x direction. And actually, I guess this only makes sense. We have to actually adjust the opposite way. We don't move that speed. Yeah, because unit speed is going to be positive or negative. So if we're going towards x, yeah, this actually makes sense. Let's see if this actually does us any better. Probably not. It did mort-ora last time, but we might have had another problem as well. And I think we crashed because we're not doing anything. So at some point we crashed. Okay, so this is the throttling was the issue here, is throttle. And when you do throttle.round as well. I mean, they could have been a bit nicer just to handle the floating point, just not to mess with us. We're not doing so well. Do we get to the water quickly? We do, but there's too much there. So that approach actually gets us, but everything's in the way, right? We're always in the way. And we tend to overshoot it a lot. So he reached 50, we're not very high. We tend to overshoot the water a lot, so that's really not a nice calculation. I think if we could fix that calculation, we could really get it to be a lot better. But it's, oh man, I'm trying to think, it's just hard to do online. I've not attempted to do physics calculations without just doing paper and pen before. Because if we do that, it's a quick X, quick Y, and well, how are we finding it first? Let's check this out. We're finding the closest rec. Let's optimize that first. So we have a bunch of things we can optimize. It's like what vector do we want to move to, what rec do we want to move to, and we're choosing the closest rec, which sometimes makes sense. And we have the I don't know. I'm trying to think here. It is, I'm not trying to think. We should go to the next rec that has overlapping ones, or do we fix something else first? I'd really like to fix the move, because there has to be a clear way to get things. We just jump over the stuff so badly right now. We don't just sit there. We start spinning around, and we don't really... Actually, let's check it again. I want to see how badly do we skip over this. It's really hard to tell because it goes so slow. We're not that bad. I mean, we really do stick in the center of those things. It's because we're getting bounced around a lot, though. We do jump right through them, but I don't know if it's because we bounce through them this lot or it's because we jump through them that's the bigger problem. And we're never going to catch up that way, so there must be something reasonable we can do. But I don't think it's the emit move. I think the emit move is probably going to be okay. And so these moves here, the skill for rage, every time we have rage, we're just trying to blow up stuff away from our Reaper. And I want to check the condition again, that it says if we emit a bomb directly on our Reaper, it's supposed to do nothing to our Reaper, but everything else around it. Creation new signature rune. Okay. Empty recs are removed. The Reapers in multiple recs will harvest 1 unit of water from each rec. If multiple Reapers are in the same recs, all the runners even when only 1 unit remains. So the center of the vehicle, we should be fine with that. That's when we launch it directly on ourselves. Otherwise, we just pick a nearest destroyer and get rid of it. But why do we go to our destroyer? We just bounce things away from it. What we should do is just screw up the other players instead. Let's make a function that takes the leader of the enemies. We'll do state, we're going to say state get leader. And this is going to return an AND unit. And there's only 2 of these, so really all you have to do is just say if enemy score 1 is less than or equal to 2, then we 8 enemy reapers 1. And we just self here. And we'll borrow them. I hope we can do that. We'll leave that there. And so now let's go to the leader instead. We don't want to march yourself away. We want to follow the leader if we can get to them. And if they're too far away, it's not going to launch the bomb, but that's okay. And we're going to make this leader is going to be, we should always be close to the leader, stealth, get leader. And here we can actually do an emit move as well. Emit move and state dot our destroyer. And we want to go to leader dot position. Let's go mess with them. And we want the skill also here. Let leader equal state dot get leader. If we're close to them, we want to get the leader position. And we'll do skill leader dot position. And for consistency, let's stick that in here as well. Fn emit skill. And cell 2, where we want to emit skill 2. This just helps abstract a little bit so we don't have to have it stuck everywhere. Print line, and we have skill. And we'll do 2.0.round, 2.1.round. That prevents us from outputting bad output. State.emit skill, leader.position. This probably has to be the vector again. And we can do the same thing up here. State.emit skill, state.our reaper, position. And this means if we're close enough to our reaper, we're going to emit the skill that scatters people away from our reaper. Otherwise, we're going to find the leader, and actually we don't want to scatter him away. We want to just scatter him somewhere else. So this would actually not scatter him. We actually do want to scatter him. So where's our vector function? We want an add and self other and vector 2. Two self.0 plus other.0 self.1 plus other.1. What we'll do is we'll make it slightly offset from that guy. We'll always push him in the same direction for now. There's probably an ideal way to push him, but that's okay. And we'll probably push him away from the water. So if he's close to water based on the destination where he's going, we should probably just push him the way away from he's going. That makes the most sense. Take his current velocity and just push him away from that. And where did that? So not position. We don't say the position dot add vector 2, and let's just say 10, 10. That's close enough. Any comments for us? Anyone here? Hello. Let's have double chat. No, I think he means on the leaderboard. You just look for his name there. Alright, so let's play this thing and see what happens. And you got an error. Of course we got an error. And this is, I don't know what this is here, but closed delimiter 262. Ah, it's this thing. This is probably hiding it. So you really have like no way to see the output 262. What are we missing? Closed delimiter. That probably missed up everything. And I think it's asking, it's you can't really tell until, I think it uses the old code. And just help this guy out a bit. Practice my German as well. I'm gonna go back to mine for now. Okay, I found integer 261, and this is really annoying again because we're adding it. F64, everything has to be strictly typed. It's kind of annoying. Okay, is it compiling or is it playing? No, this is like really slow. Okay, 261. And an AND vector instead. 267 and leader position. And these ANDs are also really annoying too. There's no way to borrow. And seeing all these ANDs and how this works, I was wondering in Leaf, I was debating whether you should explicitly have to say if you want to reference past the function or not for safety reasons. But now seeing all of these, you know, I really think it's not a great idea. It just gets in the way of what the code is doing. Alright. It looks like it's actually running this time. Let's watch what our little destroyer is doing. Our destroyer is chasing the leader. I think. And the leader is red. Is our destroyer actually chasing red? Is it messing with red at all? When he gets too far away, he stops. Because I'm guessing the bomb fails and he doesn't move. So maybe we should take a step that if he wants to do a bomb, where he wants the bomb he has to move towards if he's too far away. Okay. Or was that the doof? This is the destroyer. Which is the doof and which is the destroyer? That was 1, and 1 is the destroyer. Is that what he was? Yeah, he was type 1. So our destroyer was not moving towards it. Because if we had this rage here, we wanted to destroy something. So maybe what we should do is every loop, we should calculate. First thing we want to do is let's figure out where do we want to deploy the rage. And then we'll deal with that. We'll figure out where we want to do it. And then we'll see if he's within range, do it, and we have rage, do it. Otherwise, move towards it. That makes the most sense. Where do we want to go to? Where do we want to deploy our rage? And okay, so every turn just figure out where we want to be if he wants to emit. I think that makes sense. But if we're close enough to ours, okay, so let's do it this way. Let Reaper distance. First thing we do is figure out how far are we to the Reaper. Okay, let's do this first. Let's push function step destroyer. And this emits nothing. This does nothing. Let's move this all inside there. So our destroyer has one fixed set of things. And we want to know how far it is to the Reaper. Self our destroyer, that distance to self.reaper. And we want to know how far it is to leader distance. Self.getLeader. Distance to and self.reaper. So we get the two distances, and let's figure out where we are from there. And where do we want to go? We want to go to the leader in any case. We want to see if our rage is high enough and Reaper distance is less than, what is the maximum? I'm going to put a const here somewhere. Of the skill, the grenade has a range of 2,000. The grenade has this at 2,000, so if we're less than 2,000 away, then we're going to shoot at ourselves. F64, F64, yeah, of course. Okay. Else, if leader distance is less than 2,000, we should put this into a constant. Let's do that in a second. And state our rage is greater than 60, because that's the cost again. Should let leader equals get leader. Make this, take this. Leader.position will offset it a little bit, and for that reason we should actually make them slightly closer to take care of our offset. I'll just make this a little bit easier. Otherwise we're going to move towards the leader. These should always self. And we do this one to scare off the enemies, and we do this one to mess with the leader so he doesn't get anywhere. And we do this one to move towards the leader. So this is more of an opportunity thing. If we have the opportunity, we help ourselves. Otherwise, we mess with the leader. And we only do that if we're close enough. If we're not close enough, we just keep moving around. I don't honestly think this will help a lot, but he was sitting around a little bit, so it might actually help. And let's find out. And the way he pushes him should be better if we predict which way he's trying to go. We don't have the information about which way they're throttling, though, do we? No, we don't. So we don't actually have knowledge of where the enemy's trying to get to. We have their velocity, and we can assume that. And let's try this first. Come on, go back up here. See what errors we have. Oh, come on. 233, we have, what do we have there? 233. I'm just wondering if any of this stuff is actually going to be effective, or we're just sort of putzing about and not doing a global strategy. At least we get our little functions together. 236, this is fine. Self, then our rage. 238. Okay. Did we forget the step the destroyer? We did. State.step destroyer. The day is my enemy 666. Hello, welcome to the show. We're trying to get order here, seeing if we're doing any good. Uh-oh, I think we crashed because our cars are not moving. That's the typical thing that happens. We crash means our car hasn't moved, and that's because I forgot to put that in. So let's play this again. I just added that now. The popular formula. Is there a popular formula? Do we want a popular formula? Oh, 1.5. Okay. We can do that too. I've been meaning, I want to actually calculate a thing, but I can't do it online. It's something I'm actually going to have to do offline, is collect the actual ideal formula. But let's do it this way then. So, we're told this is the popular formula. And the destroyer, yeah, we're just running interference. Again, I would really like to make this emit move, be even more clever, because this is really just an estimate. And where's our destroyer? Our destroyer's chasing the leader, being kind of a dick. And is it actually helping? I don't know. He's just kind of being a dick, but our car is being an idiot. Our car managed to collect a lot there. We collected a bit more. Our destroyer thing hasn't helped a lot. We really haven't helped much at all. And so the destroyer's here. So we probably don't have enough to do any better than that. Well, let's see if we get any better. So we're at 175. If we submit this, we're probably not going to do any better, but let's just throw it in there. And where'd this come from? This is new. Oh, showing where we are now. And so we're not doing a lot better in this board. It looks like we're basically doing utterly random. And so that's not good. So we need to worry about something else. And I'm not going to be able to do the emit move. I'm not going to do the optimal one. If the popular formula is just to estimate that, then that's where we have to go to. We'll do with that. But what we could do is we could say that let's not go to water where there's stuff in the way. Let's find the cheapest path. We can actually start finding cheapest path stuff, and maybe that actually gets better. Maybe if we go the direction where there's less interference, would it actually help any? Would that actually make a difference? But without knowing our actual path there, it's hard to say. We're going to have to calculate a lot. So we've fallen. But that's because we have to go up and down. So let's just kill this out here. So we have all sorts of options. Optimal, like the emit move. I think we need another one. We got to look for overlapping water first. So that's the next one we do. I don't think this running interference is making big enough difference. We may be better off just running and smashing a bunch of water up. So if we're near a water tank in ours, or we can look for overlapping water. So we can look for water density. Wondering how much effort we have to do to collect that. Do I have to do like a k-mean square to find out where the water is located, or can I do a cheaper way? So what we can do first of all is when we say, let's put this into a state.step reaper first. So we clean that up. We'll do a step reaper. We're at least going to look for the ones where there's a lot of water nearby. I'm not quite sure where you mean that, the day's my enemy. Where are you thinking to write that? Rec minus. In terms of closest rec? Okay, that might make sense. Where is our closest rec to, based on our velocity? Let's try that right after I fix this. Do you mean to calculate, yeah, do you mean to figure out where the closest one is? Or how to get there? Both. Okay, both. Okay, so we have closest rec. Yeah, okay, well let's look at that. So stepping reaper, the closest rec. let's do both of those first. Let's do the closest rec. And so we're saying 1.5 is a popular formula. I'll work this offline, but we can do that here. And so we don't want unit distance to, we want actually estimate our position. So we're going to say estimated position is going to be unit.position plus, add unit.speed multiply 1.5 f64. So this is what the estimated position is going to be. And so we're going to find the one to the target position, estimated position. So we're getting closer here. And so instead of saying where we are now, well, let's add our current speed, because that's our best closest position. We're not going to keep switching distance to it. And what we could also do is we could put a scoring on these. The ones with more water, I was thinking, if there's more water in them, they're more valuable to us. But how do we rank this with the distance and stuff? So it takes one turn water. Let's just do a score here. Minus self.rexi. And what do we call this again? Water. So we're gonna overvalue things with water in them. So things with more water get more points. I don't know what the correct value is for the weighting. It's something we do. Maybe base it on max throttle, because that's how many turns it would take to get there. And let's see if this helps us a little bit at all. And then we'll do with the actual moving code to figure out the same thing. Once we see what our errors are. Because of course I have errors. There's no chance I don't have errors. No method multiply. Did I not write a multiply for the vector? I wrote a divide and not a multiply. So let's write a multiply. And self scalar f64. Vector 2. Let's run this first, then I'll try. Yeah, it's right. I should just take the score. 1 divided by distance times. Yeah, okay, that would probably work too. Let's do that as well. Once I get these stupid things found. 56. I can see half my time's fighting with Rust. Node there. Let's go to 206. Estimated position unit.position.add. This pisses me off. What's the problem here? Oh, this is going to be F64. Okay, I'm going to get back to what you said. Today is my enemy. I got to fight with the Rust for a bit here. And this editor, I complained about it, and hopefully they can fix it. It's just getting really... And this is really getting annoying here. Okay, mismatched types and unit 208. Okay, this is rex.position. Forgot to pass it. As F64, it's integer. Self.position. Where is self.position? Where did I do that? Line 255 is wrong. Reaper dot position. And let's do that with the code right away. And so we're going to say max unit and max score instead. We're going to make this a score 0 and we have none. And anything with a better score, we don't even have to say option here anymore. We can kill the option bit. Just start at 0. Oh, we'll just leave it just in case. Okay. And so the score now is, we're going to say, we'll take the days my enemies approach and say 1F64. Let's open this up a bit more. Times, that's a huge number. 10,000 F64. So you're really, really valuing the amount of water they have there. Did you really mean 10,000 and not 1,000? Well, let's see what happens. If it works, it works. Oops, I have to change these things. And max score. Ah, come on. If max unit is none, max distance is max score. You have that in your score function. Well, good, then we'll just take yours. It's not cheating at all, no. Okay, score, 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 score. Yeah, I mean, the value of water is worth a lot, because I noticed that you waste a lot of time. If there's something with 2 water, you're far better off going into than one with 1, even if it's across the board. Though I'm wondering if the score function should actually subtract anybody else that's close by. Well, we can do that later. We just want to do one step at a time and see if we actually get better each time, max units. And 255, we still have an error. 255, self.reproduction. Our Reaper. Is it actually going to compile this time? Okay, so it's actually going to run this time. I think we crashed because he absolutely didn't move, so we emitted something wrong again. Stop that. Wait a second, we never stopped. Well, that doesn't make sense. Something went wrong there. Why did we stop? I don't think we actually did. Performance in these things is so bad. So he sits in the middle until there's water there, that's fine. But he doesn't move. He's just not moving towards the water, so we screwed something up in that formula. Our other guys move. He just doesn't move. He's being an idiot. Stop this. Why is our Reaper not moving? Closest rect is... Well, it is moving somewhere, but where? Just getting weird. Where's he actually moving to? Trying to debug in this tiny window. We are going somewhere. We're not sticking somewhere, so there's something wrong. But we only changed the scoring function. Closest rect index, if we have some, otherwise we go to the middle. So we have some. And we screwed this up. Why am I moving to myself? What on earth did I do here? I don't know how I screwed that up. I just wish it wasn't such a poorly performing little graphics thing here. Alright, he gets indecisive, and that's bad. We don't want indecisive. I think if once we've picked an ID, we should probably stick with it. Like, wow, look how indecisive he gets. We got something wrong with the scoring function there. We're really getting nothing. So we made it really bad. So we're so indecisive. Too many carrots on the board, and we just do nothing. So one of the ways we could address this is actually say, if the thing we decided to go for is still there, then just keep going for it. Don't actually become indecisive. Once we've committed, just go to it. Or we can first take a deep look at this thing, because it's highly unlikely that it changes that much. Yeah, right here. This is the problem. We had distance before, we changed the score, and we forgot to change the comparison. So that made him indecisive. So let's... yeah. That's the one, we just had the less than. Because I was comparing distance before, I had a less than right here. And that will make him very indecisive, because he would just continually switching. He's still not so decisive. Yeah, I'm going to have to... The emit move function, I'm really going to have to fix the emit move function, because he just goes way too fast over the things. He just skips them. And... so we have the one with the best score, and we go there, and that's what's causing him to bounce around like an idiot. Still, and we have the best score, but we have to commit a little bit, because he gets in. The moment something else appears, it's going to keep going there. So let's just try that. Let's actually just track which one he was going for. Does anybody know if these IDs of these things, do they increment every single time? The unit's ID. So let's track that in the state. State definition for the Reaper, we're going to have yeah, we still need to do the overlapping. I have to consider that as well. I want to try this first. I want to say let's commit to something. Target ID for a Reaper target ID. Reaper, it's getting hard to type. Reaper target ID. And this is going to be, let's just do an I-32. And what we're going to do in this closest rect, or we're going to say TEP Reaper. We're going to say if, we need to know all the units now. If has unit self Reaper target ID. Let's just keep going there. And here we're going to say self dot Reaper target ID equals rec.id. And we're just going to commit. We're just going to pick one and commit to it and see if this, I want to see what difference this makes. And then definitely getting the one with more water. And I think we should actually score things if there's crap in the way. And this is the one I'm trying to avoid so far because it's a bit of work. If there's too much in the way between us and the water, we should reduce the score a lot. Like if it's heavy contention by the water, that's got to cost us something. And so self.emit move. Actually, let's do this. Let f unit equals self.getUnit self.reaper target ID. We'll make that an option, so we can say if unit is sum, omit move self.rreaper to unit.unwrap. I think that'll be that. And then I need a function that finds it. Function get unit and self. Then we need the ID, and this is an I32, and it returns an option unit. I think it's an AND unit. May need to be mutable. I don't know. I don't know how that works actually, to be honest. This gets to be a real pain because we have all these units and we don't actually have a combined vector of them. And in another language, what I would simply do is have a list of units of all of them, but, and this is where it kind of sucks, Rust won't let us stick the same unit in multiple collections as far as I know, because you can't have mutable references. So we're going to cheat for now because we know it's just rex. We know we're just going to rex. We're just going to look through rex for the moment. If self.rex I.id equals ID, return sum and self.rex I. So we're kind of cheating here right now. Return none. We'll see if this actually works. And we have to find a way to keep all these units in memory in one list. And like I say, in any other language, I would just stick them in multiple arrays, but I don't think you can actually do that in Rust. We'll try it though. 91 is supposed to be something else. Expected function found none. Did you mean to write none? Okay, it's really weird that it's just none. 265, what do we have? Emit move unwrap dot position. Hello, Sasha. We're trying to get the water. We're trying to optimize the moving. Well, not the moving, the actual figuring out which target we want. Oh, this is getting... I've never pressed page down so much in my life, I think, in one coding session, as in this editor. It jumps us to the top every single time. No, come on. What do I do now? Oh, show those bobs, yeah? We have warnings and we have an error somewhere. Step Reaper. Okay, Step Reaper has to be mutable. Come on, stop doing this unused variable enemy rage 2. I don't care about that. Why not? Ah, come on, this is 263. It references to fundamentals as well. Alright, this works. And this is actually really kind of frustrating in Rust to do this. What's the problem now? What is its problem? 263. Hello there, Radical Lusra. Glad to have you on the show. Hello, Inkoyan as well. So 263. I think I'm hitting some Rust problems here. Self.getUnit. We borrow the ID, which is, I think, fine. Affiliate, yeah, yucky borrow. I don't know how to deal with it. I just want to send this ID to this function here. And I don't want to borrow it. I just want to pass the value. But it's getting mad. And it's getting mad down here. Cannot be dereferenced 254. Yeah, I forgot to change that. Come on. Anticipation. Okay, this window really sucks here. I mean, coding game people, please fix this window. I can't read what this thing is. We can't see the whole thing. So line 263, I'm actually getting stuck on the stupid Rust right now. I have a function that takes an ID. It's an I32. Borrow of self-reaper target ID occurs here. Assignment to borrowed self-reaper ID occurs here. Why can't I do that? I can do something stupid. TID equals self.reaper target ID. Okay, I don't know what the issue is now. Cannot assign to because it is borrowed. It is not borrowed. Leave me alone. It is not borrowed. 264. How do I avoid this? It thinks because we borrowed it here that we can't assign it down here. And that's just annoying. What if I just stick braces in here? Can you do this in Rust? Organ grinder. Hello, organ grinder. Welcome to the show. So that this is really weird. This is something I don't understand. But let's see. Let's check if we get this. So we commit to IDs. That's fine now. So we're a bit more stable, but we all bunch around like idiots. we're not doing well. At least we commit. Okay, this committing, it doesn't work so well because there's water right beside that we could get, and we just ignore it. But we've run out of time. We've certainly reduced the influence a bit. Yeah, I'm debating what algorithm is the best here. I'm wondering how much this expert system... Yeah, velocity is the thing that we have to fix. I know Argon Grindouts, the biggest one we have is my emit move function is using just a rough estimation, and it's very bad. It's very bad at getting to it. And so emit move here is x. You mean for the target? Yeah, Rust is definitely not a nice language to coding here, but so in Koyan, do you mean like my target x should be this? Because you already take the x as minus the unit speed. The 1.5 is the max number somebody else got. And you want to multiply it by the max throttle as well. Okay, but I think my my target idea, I think we've confirmed that this is not a good idea. If false, bad idea. This looks weird. We're going to go for the indecision approach first. And we're not making a lot of progress here at all. So we got to 136 last time, which is actually improvement. And yeah, I'm just wondering, because what I'm having a problem is I can't actually, I can probably work through this. And I can't do this in my head on the show. I'm thinking I actually have to do this off the show, is actually sit down on my piece of paper and calculate what the correct emit move is. If I'm trying to get to this target distance here, what is my optimal speed? Assuming there's nothing else on the board. What I was thinking of doing overall as a strategy is, this is why I started splitting this off, is I'm actually thinking of, I want to get all these basic, I was hoping to get all the basic sort of inputs we can have, the distances, the max rex, and scoring all these things. And then whether we use a genetic algorithm or we use a few neurons or something to actually let it predict and get us the values out, I'm not sure. But whatever we have in all cases, this emit move has to be better somehow. And we have the speed, and I don't know how to quickly do that up. I want to see where we are again now. If I remove it, what was the problem we had here? We're come on. Like, it's really hard to see what's actually going on because they're just like randomly stuck. Well, maybe we should just add the overlapping water score first, so at least we cover that. If there's water on top of each other, it gets more valuable. But there's overlapping water right now, and I guess it does happen often enough that it might be worthwhile. Like, if we actually went for overlapping water, we would have easily won this one. So how can we quickly do the overlapping water? closest rec. So it's not the closest rec anymore. I'm going to call it best rec. Closest rec. So these are all going to be the best one now, and we're going to try and score that better. I still move like kind of an idiot. That's fine. We seem to get close to it. I think if we chose the closest one better, moving like an idiot would still actually work. And so how do we want to score this? We have the ones that the water's worth a lot. 10,000 divided by distance. That might be fair. Higher value ones are worth a lot more. We might want to tweak that a bit. But let's figure out what other values are there. Is we're going to pick another function, so we're going to give it a water score for a rec. And we don't even need the state itself. Yeah, we do. And we're going to need a rec. And this is going to be an F64. And we'll say times self.waterscore. That's what I'm just about to do, Organ Grinder. This is why I'm doing a water score, is I'm actually going to calculate the water score based not just in overlapping, but where there's groups. Yeah, that's what I want to do. Yeah, I'm not doing that. That's what I want to do. And that's what I'm just about to do now. And so we're going to start with a score. We're going to say score, let mut score equals 10,000 times. Actually, let's just do it this way, times 10,000. 10,000 times water score. Or, I don't know, we'll figure it out. We'll figure that out, and that score equals rec.water. And now we're going to look for all the ones that... Rayasura, is this coding game any good? We're enjoying it. I mean, it's okay. There's a few issues with the layout here. As you can see, this game information, this console output's a kind of a pain in the ass, and that's for Rust, and the output doesn't work, but otherwise it's kind of fun. We get graphics. So I would suggest trying it, because the graphics make it a lot more interesting than staring at a console all day, and you'll see right away when I get this running again. But let's do this. Let's try to find for I in 0 ... self.rex.len if, okay, let target equals self.rex I. We probably have to borrow this. If target.id equals rec.id, we skip it. Continue, because that's ours. Or an easy way to do that. And now we want to know the distance. Let distance equal target.distance to rec. Do we have a radius on here somewhere? I can change the background color. We're going to change the background color. The external editor only works with Chrome. I was looking at it because I don't like this editor, but I don't want to run Chrome, so none for that. So we're going to do this very roughly first. If distance is less than rec.radius, actually, rec.radius plus target.radius, we're just going to ignore that. We're going to say the score plus equals target.water. This is extremely rough right now. We can do it. Well, I'll be here for more than a month, right? Or if you're looking for that, I should be here a little bit longer. And yeah, the contest here, the next one starts in March or something, and I am hoping to get Rust well enough. Okay, so anyways, we have this water score here. And what I've done is simply, if there is overlapping ones, I just add the water together. It's not ideal because we're not actually going to go into the overlapping area, but at least we'll be close by. Okay, now I of course have errors. Unnecessary parentheses around if 281. Yes, definitely coding game isn't one game. There's a whole list of these things. This is just the first one we picked because I foolishly thought this might be an easier one. It is not an easier one. Give me a 209. We have something wrong as well. Okay, what do we have wrong in 209? Oh, this has to be an F64. And don't let the Rust dissuade you here. The Rust is making this a little bit difficult than it is because I actually don't know Rust. And 235. Score equals wretch the water as F64. Actually, we don't need that. We can just do F64 as F64. When we started this show, several shows ago, like 8 shows ago, which one's CSB? When we started the show, we did the practice stuff, and we kind of got bored of the practice stuff, so we came here. And we're going to work on this one a bit more. If we don't get further, that's okay. You're actually here for the Rust. Well, great. We need somebody that can help us with the Rust, okay? Because we're not. This is why I'm here, as I'm learning Rust. And anytime you see something that looks, crappy, just let us know. Well, you can watch. I don't like making decisions. You'll hear my commentary on some things that bug me a lot, but it has some strong points, and that's what I'm trying to find out. Okay. So now all we changed is hopefully if there's overlapping water, we treat it with much more value. Or not just that, if there's any close by, so we treat groupings of water with more value. Actually, no, they have to be overlapping, sorry. Only overlapping will give us more value. But we seem to have a similar algorithm as the other guys because we all go for the same water. We're still not doing here, but okay. So I'm having a hard time judging here because this is really chaotic. And there's overlapping, and I ran for the overlapping very fast, which is good, but we ran out of time again. Coder Strike Back. I was actually looking for which one is Coder Strike Back. You must be doing something. Thanks. Yes, right. So we're trying to grab the most water, and we can deploy some bombs and stuff to shoot other guys away. And we're looking for water. Okay, so yeah, clearly, what are we doing wrong? Why do we not get to Super League? Well, we're going to try. We'd submit this. Maybe we get farther this time, right? We're clearly doing something wrong, and let's go over the whole strategy again. I'll say what we're doing, and we'll see where we are. So, on each step, we'll read the new one in, and we step the Reaper. Potters. That's what it was. That's the one I wanted to do. Last show, I was actually looking for it. I was really wondering what we do, and I couldn't find it again. But I'm going to stick with this one. If I don't get any further with this one, we can go to the other one. I don't want to stick with just the one game too long, because I think you guys get bored. We can switch back and forth between games. And tomorrow night, we can start the other one if we want. I'll see where we get now. Okay, so the overall strategy, we do it. That's what I was going to say. With the Reaper, what we do is the Reaper, we're walking towards the best water. We've got a poor algorithm for getting to that water. We do a slight overlap calculation, so it should be okay. The Destroyer, what the Destroyer does is when he's close to our Reaper, he bombs our Reaper to scatter other people away. Otherwise, he follows the leader. He follows the leader at the moment and just tries to interfere with him, just by bumping him out of the way and bombing beside him, throwing him off his course. The Doof does the same thing. He just chases after the leader, generating rage, and whenever he gets a chance, Well, he does it. All he does is he chases it after the best Reaper. You can see it right here. I'm using the old functions. He's chasing after the best Reaper just to bump into him. So if you're saying I should get further with this, we're clearly doing something wrong. Something simple wrong, because we actually have that strategy. We're running interference. We're bombing where possible. We're not getting very good to the water. Oh, you mean my destroyer? So you mean my destroyer should not follow the leader? Where should my destroyer go then? Right, I have this thing. The destroyer code is right here. Yeah, I wasn't sure what to do with the destroyer. He was normally following me. If he's close enough to me, he loads it on me. Otherwise, he follows towards the leader. We have the destroyer. The destroyer actually destroys the tankers. And it's uncertain if we should actually do something with it. Okay, so let's skip this. Let's change this code. We're saying now that we're not going to chase the enemy leader. If we have rage, we're going to mess with the enemy leader. But otherwise, don't chase the enemy leader. Let's get to the closest tanker beside our Reaper. So we need a function closest tanker. Closest. Okay, we don't have closest yet. And this is where I don't have a generic function yet saying closest, so we're going to have to close this. Let's closest tanker. Let's just call it CT equals self.closest tanker to our self.our destroyer. And if ct.is sum, then we're going to emit a move towards it. Where we're going to ct.unwrap position. Else, where are we going to move it to? Yeah, the kind of listen that I was thinking about that before as well. I'm just trying to do one. Yeah, we can do that. I have to encode more of this. I've been trying to improve the Rust because a lot of these strategies are hard to play with now because our code's kind of a mess. And we should definitely wait. That's what I was looking for yesterday. If let some CT equals CT, good, that's the syntax I was looking at. I was trying to look that up yesterday and I couldn't go through my chat again. Yeah, okay, I've been meaning to, that's what I say, radical implicit, we're going to step towards that is slowly we're going to move all of this into score functions instead and then find a generic way to do it. I don't know if I'm going to use GA or I'll use something else, but clearly all of this scoring has to be broken off into scoring functions so we have clear inputs to some sort of more generic algorithm. Can we idle in this? Let's just go closer to us then. In the odd case where we don't have a Reaper position. I'm not so good with all of these simulated. I'm not so good with the artificial intelligence, as you realized. I wasn't planning on coming here to learn artificial intelligence. I was here to learn Rust, but clearly I'm going to have to get into that a little bit more. And my limited knowledge of artificial intelligence is a little bit with neurons and some statistics functions. That's it. So we move towards the leader. So our destroyer does not go towards the other leader, he goes towards us. Let's see if this actually helps us at all. Oh, I forgot to check if we probably failed. Closest tanker. Yeah, we're going to have to write the function closest tanker. Did I actually write that? No. Closest tanker. And I'd really like to have a generic function that does this, but I haven't quite got that there yet. And I'm going to say to which unit. And it's option and unit. So it might not be there. And we're going to start as let mut option and. Wait, got this backwards. Closest unit starts as none. Closest distance is going to be an f64 equals 0 f64 for I in 0 dot dot self dot tankers dot len. We have let distance equals self dot tankers dot position dot. Actually, I think we just have a distance too. I wrote a convenient one, distance to unit. This is going to be an and as well. If cl unit dot is none, or do I not have to? It's been failing on me a lot for the type annotations. That's why they're there. I'd prefer not to have them. If I don't need them, I'm quite happy to get rid of them. Or distance is less than CL distance. I'm guessing there's a much cleaner way to do such algorithms here as well. Then we say CL unit equals and self dot. And we can actually do this, I think. Yeah, this has been my approach so far. Self.tankers, I. Oh, this is supposed to be I. CL distance equals distance, and then we don't return it. We just say CL unit. Let's see if that actually works. And this tiniest console window in the world, we're going to see if we have errors. It's taking a long time. We do have errors. 269. CT position. 282 just a second. I'll get to that. It's none. No, we don't have to register because that's why I'm starting with an option unit of none. So if we don't have one, or the distance is less than. Submit into legend already. Self.tankers I. Yeah, okay, that has to be a sum. What legend am I submitting into? I submitted just very recently. After this one, I'm going to submit again, and we'll see if we do any better. Which legend? You mean like the legendary practice? Oh, look, it's actually doing something. Yeah, I really have to fix the emit move function because there's a lot of opportunities we're just completely missing. I think if I would just better go to these things and stop on them, I'd be a lot better off. There's still some indecision there. We're still overshooting. Okay, we're just not doing any good. Alright, let's submit this first and then I'll make that change. Alright. Got that. So emit move. Emit move. We have a better estimation. Oh god, do you see the error I made? Do you know why it's not working? Look at this, we've been calculating x and y the whole time the way you guys are suggesting. But then as an idiot, I'm passing the original to function. So these calculations we've been modifying are doing nothing because I'm just passing the fixed target. That's why this is not doing anything at all. This should have been 2 and x and y. So, that looks like a very simple bug there. Because Nkoya, and that's why I've been saying I've been doing this right here. And the 1.5 is coming from other people as a better value than just 1. But if we just ignore the value, it does nothing anyways. So let's see if that actually has something. We don't quite get there, though. Are we indecisive, or do we not quite get there? When there's too much water, we don't do much. And what we're going to do is we're going to kill the throttle. I'm currently doing a throttling the distance here, but I think I'm doing it too much. So we'll just take your guys' approach and just not overshoot, but we'll keep the throttle at maximum. Or I should calculate my distance based on this modified distance. No water, guys. There's no water in this level. I don't know if my algorithm is changing because there's no water here. No, it just doesn't get to it. We just stop right before it. Okay, we have something wrong there still. Something is very wrong because we just stop right before the water. So if we shoot to there, we're just stopping right before the water. And F164 instead of 1. And we'll say the 1.5. We'll put that back later because I'm not sure about that yet. So let's say adjust. And then we're going to put the throttle bit down here. And vector x comma y. How do we get there? Yeah. Rough, horrible fix. There's something wrong with the emit move. And now find function vector 243. Okay, yeah, vector 2, because these are vector 2s, everything's a vector 2. So what should I be setting my throttle to? So if we do the x2 minus speed, what should we be setting the throttle to? That's a quick solution to say don't overshoot. Well, this looks actually better. No, we still don't get to it though. Something's still not right. But what about throttle? What do I set throttle to? I'm now just minusing the velocity, so I'm taking the destination minus velocity. So I put the adjustment to 1. But what should I set the throttle to? So this is the unit, this is where we want to go. The unit's current position, not the unit's current position, the destination minus the velocity. This is exactly what we do now. And I'm just not seeing, I must be missing something. So just 300, that's all I should ever do. Shouldn't it matter? Well, apparently it does matter. Because, it's hard to tell. You notice how it's always just stopping slightly in front of the water? Or not that time, I got lucky that time. Like, look how often it just sits there. Like, we're just not getting on top of the water. Indecision again, indecision. Our closest water one might be wrong. Yeah, I'm going to check that now. So the throttle is always 300. We'll leave that at that. Just minus speed. We'll drop that. And when we go to Step Reaper, we drop that part out. Best rec. Best rec. Unwrap, rec ID, we're removing it, we don't care. Rec dot position. Where is our best rec? Best rec is right here. So our best rec, what we do is we're scoring it. And we're taking the suggestion from, I've forgotten who, sorry. The distance to the position times the value of the water score. And the water score, what I'm doing is I'm calculating overlapping water. So the one with best water is the one that's considered closest. So the more water there is, the more score it gets. Whether this factor is correct or not, I don't know. And water score, score. And we do that for all of them. We do it inefficiently, but that shouldn't be the issue. Distance to self. The estimated position was adding the current position plus the speed times 1.5. Okay. So we estimate the position based on our speed. Well, that's what I was doing before. I was actually tracking, I was committing to a pool. I was committing to a pool before. Simply the moment I decided, I said, well, let's just do that. And it was working bad, but I could reinstate that code that we fixed the initial thing. Maybe I can reinstate that code, this one right here, this bad idea code here. And this was actually, it was doing the indecision. This said it commits to it. As long as that ID's there, just keep going to the same one. Let's see what happens if we go with that again. And I say, I'm worried that maybe there's something simple in my Rust code I'm still missing. See, it's not indecision. It's an inability to move to it. So our emit move function is not getting us to the place where we're supposed to be. Because he's probably still going for this one here. And we can actually debug that. Emit move, emit move. What does a string look like? Yeah, there is. I'm going to do that right now. I just, when I refactored it, I lost that message. This will be an and stir or something. Alright, thanks for working, Well, hopefully we'll figure this out. I should be back tomorrow. If I can't get past this Bronze League here, I might go into another one and come back to it and fix the emit move offline, because this type of coding is actually something I should be good at. I've done lots of physics and stuff. I'm just having a hard time thinking quickly online. Okay. Anybody know how to do a default argument in Rust? Can I put a default here? I'm going to find out, I guess. So where's the emit move? It's horrible. Emit move. Default args. Okay, so we're going to find all the emit move places. Emit move. And there's no way to search again here. And where are we trying to get to here? We're trying to get to tanker. This position, he's going towards the Reaper. To Reaper. I'd probably be a lot better at C++. I know C++ quite well. Okay, Control F, edit move. Where is he going to? Step Reaper is going to fixed. We'll make that that. And this emit room is to new. So one phase he'll be doing that. And otherwise he'll be going to the center. Yeah, but you can't overload. It's kind of annoying. So I'll just do the one function and just pass a message every single time. Where are we at now? Compiling. I'd be surprised if this works the first time. It worked. Okay, so we can see what these guys are doing now. So he's going to the center. He's going to a fixed puddle now. I should have written the ID. So he's going for here. We know he's going for there. But our movement function doesn't get us there. And so our movement function is fundamentally flawed. And so now he found a new one. And he's trying to get to it as well. And he just doesn't get to it. So I think our movement function is fundamentally flawed. And so I'm going to do this. I'm just not going to adjust it. I'm just going to go instead directly to it. At least we go to stuff now. It's not ideal, but the indecision is gone. And he's collecting a lot of water now. But the other guys are still faster than us. And well, let's find out if the rect coordinates are correct or not. Well, now he's going to the best water. It's fixed. Yeah. Zuberland, I definitely want to do that, but right now I'm suffering. He's clearly not going to the right place. And it's not just the cost function. Our emit move is not getting him to the right place. So as Rhyosaur says, or Incoyan says, are we going to the correct coordinates? Yes, I believe so. Let's go back to closest. We do something called best rec. And this actually returns the rect. It's not returning a position, it's returning the rect. So, and we're going to the rect position. So I'm fairly sure we have the right position. And I don't think the position is wrong. Unless all of our positions are wrong. We've never checked the parsing input. And yeah, theoreticals. I'm actually not sure what I want to do with this. I'm really guessing that I understand this approach, this expert system approach, is just going to completely fail beyond the simplest stuff, because if everybody else is using any kind of artificial intelligence, any of those algorithms, an expert system simply cannot compete with that. And what I'm curious with right now is simply I want to just keep fixing the rust. I want to split this off and see what works and get this working. And I want to understand why this function isn't working, because I'm not so sure our algorithm is totally wrong. I mean, the expert system is clearly not the right approach, but there's something else going wrong here, and I'm trying to figure out whether we're just making stupid decisions or we have a coding problem. And that's the main thing I want to solve here. And when we go to the other ones, we will take a different approach. I was really thinking of, in the other approaches, I will just base it on a more a lesser approach, a scoring function. Like, I was really hoping to just move these all to scoring functions and use some other approach, but I just want to fix this now. I just want to see if I can access the basic things still working. And there's clearly something wrong with the emit move here. And that's what's bothering me the most, is it's this emit move, we're just not going to the right place, and that's what's bothering me the most, and I'm trying to figure out why. And that would be the same thing with with an AI with a scoring function. If we're just not going to the right place, it'd make no difference. And alright, so let's keep looking at what we have now. He's getting hung up. He's going to local water, the rect coordinates. I guess we have to check the rect coordinates. And I don't know how in Rust. How can I format a string? Anybody know how to format a string to say where he's going? How do I do that? I really don't know how to do that. I want to put it right here. Oh, I guess I could stick it here. Sorry, I have the formatting right here. Yeah, let's just stick it like this. Let's just see where he's going. We have to have one long enough to see what it's there at. Now he's having no problem getting to them. Alright, he's going too fast now. He's not getting stuck. Come on, this is so hard to debug though, right? I just need to see one. Was it the right place? 2120. Doesn't look like it's the right number. $1785, it's the correct number. I verified the one, it's the correct number. We're going to the right place. I'm fairly sure we're going to the right place. Actually, we can pause this stuff. Let's just double check that. So where he's going to fix 292, is there one there? There is one here, 2932. There's water 5, and he's going to that one, I think. We can't really see the whole thing, but I'm going to base the fact that the X is correct, that the Y is correct as well. So we actually do have the correct position. It seems like a reasonable place to go. And I just don't know why he doesn't go there. From what the other people are saying, this is supposed to be good enough to get there, but we're just not getting there. We just do not get there, and we'll just put a space there. Yeah, I think I'm going to the right one, though, because I don't think the Y is going to be wrong. He looks to be pointing in the right direction. And we're trying to get to the target there. I'm uncertain now of why we not be moving there. I ignore the distance now. And we don't want to, we just set full throttle. We don't adjust the speed. And how do we want to do that? This is supposed to work. Getting a little bit frustrated about it now. Let's just run it again and see. Do I maybe have this running too fast? Is that my issue? Do I have like the graphics on too fast? Let's slow them down. That looks about correct. We see the 4. This we understand. They're jamming there like idiots. That's okay. Then he goes to the next one. Then he goes to the next one. Then he's going to one over there. Then over there. Like, he's doing the right thing now, but it's not. Yeah, that's the next thing. So if we put the adjustment back, so let's put the adjustment back, and then we'll see. Let's emit his speed. Instead. Because I guess everybody's general opinion is that if this emit move, if we have the right destination that we do, is that this should probably be going to the right place with the speed adjustment if we adjust the target X. Oh, that's not very friendly of it. No. His speed appears wrong. That would explain a lot if the speed is wrong. Speed is wrong. Wonderful. Well, where am I getting my speed from? Thanks for telling me to check that in Koyan, because that would be... We read the speed in speed vector. Oh, wow. Well, this is another one. You can put your hands up if you can see the error here. You know, we should always check this first, Vx and Vy. And so, thanks a lot for that, and quite... Yeah, I just bow my head now. Just pretend you didn't see that. Well, we've optimized the other stuff, I guess. In Horizon, it's clearly I was just passing the wrong values in. We're parsing a Vx and a Vy. There's a Vx and a Vy parsed right here. I was just passing X and Y in. And this is one of the hard things about doing this online and with this debugger and making it so long is that I don't check a lot of the things I'd normally check. And I would really be testing this a lot more, but let's see if it gets there now. The first one looks good. It's going to another one. Why is my destroyer not smashing something? Okay, I'm going to put the speed back up because it's taking too long. So he gets to the places a lot better now. Whether he's going to the best place or not, we don't know. There's still stuff stuck in the way. That's fine. That's fine. And we're going to go back and do the adjustment of where's our emit move. Go to the 1.5, 1.5. We don't. I can ignore the throttle thing. We said maximum, and we said we probably don't need to go to the lock position. So let's do it false. We don't need to lock, and let's just submit it. If we have a compile error, we're going to get 0. And well, one of them is good. This list looks good. This looks really good. And if we keep up this rate, we should be okay. So we already got up to 72. Up to 51. I can't believe that stupid mistake. When I first wrote it yesterday, I was writing everything out and checking if it was correct, but I apparently never checked the speed because we just didn't use it. And up to 41. This takes a long time to run these, but these are looking like, the sequence here is looking really good. Up to 27. Oh, please just keep continuing this way. We have a lot of battles to go through first. So let's let it run for a bit. Keep us surprised. And so what the mistake we made again, for me that didn't quite catch that, is well, it's kind of my issue with I'm not quite used to this headset. They give us all of this, like Coding Game emits all of this stuff. So they were parsing. We have to assume they're parsing it correctly. Although now there's legitimate reason to think they're not parsing it correctly, because the competition we just played earlier required you to parse the input as a string, and they were parsing it as an I32, so I lost it because I didn't have time to change the algorithm. I still would have lost because it's code golf, but so in this case, no. We have the Vx and the Vy. I was just doing the wrong ones, and in general, how could have I reduced that mistake? I'm not positive there, but I was looking at it the first day, and you know, ideally I'd have a test case, and honestly, I really do test cases for these things, because it would really help, but online I don't have this. I would ideally have a test case at the end that just checked it based on the parsed input, do I have the right values? And I don't really have a way to do a test setup right here unless I do out-of-line coding, and so I don't know how to avoid it, but other than just being really super careful here, maybe I wrote this bit when nobody was looking, and so nobody saw the fact that it was just X and Y again. But that absolutely certain. We're at rank 5 right now. If we look at the leaderboard, and we're back to rank 9. But since we're going up, I don't know how we'll do. We might be okay. If we keep our win rate up, we should probably get up there. But that emit 2, as I say, the emit 2 is still not ideal in my opinion. It's a rough estimate, but it's certainly better than what we, it certainly gets to where we're going now at least. And the destroyer, we changed this to go to the closest tanker. Whether that really helps or not, we don't know. We didn't compare without. Yeah, I don't know how to parse in Rust. Like this is all coding game. It does look really ugly. I have this nice structure here that reads it in, and I would like to find a way to read it in. I'm sticking with this. I think eventually I'm going to have to find a way to read this better. There must be a way to do it that I can just read directly into it, but I don't know. And we'll see. So what else can we do? We have the scoring. We have the closest rec. We know which bits we can improve. And as, well, who was it said? Yeah, as the Radical was said, this overall approach to such games like this, it is wrong. We're doing what's basically known as an expert system. We have a bunch of if statements. We're assuming that I can logically think of the best strategy to win this game, and that's very unlikely because we have intelligent agents. What we need to do is we need to readjust this all. And this is what I was doing with these functions. Things like water score, this is the function you'd want. Best rec, you're also okay with this. You want to write a bunch of these scoring functions and then stick them into any of your choice of machine learning, AI, or statistics functions. And if you stick those in with your general output options, you're going to let it adjust dynamically and hopefully come up with the best solution. I'm hoping this gets us to the Silver League, because then we might start something else. But we're sticking at 6. We're having a hard time. We're still going up. There's still a lot left to run. We might be fast enough. We're still going up. And I honestly don't know how the ranking board here works, whether we play against other people or we play people at random. That is, as we go up, does it pick people from the same ranks to play against? Or do we just keep picking from the random of the complete set? I don't know how that works. I'd actually like to know how that works, because it seems as we get to the top, our speed up seems to slow down. Or that might just be because the other algorithms are doing extremely well, and so we're actually... Okay, so you do play people around you, so that would explain why I slow down. Okay, and that explains a lot, but it looks like we're still going up. And so we're probably going to... Do we play against Crazy Max? But not higher... Yeah, that clear not higher leagues. I'm assuming that, because otherwise I'd be near the bottom. And do you know if we play against Crazy Max as well? Do we play against the actual... this guy, I guess. Or just the other people. And so we might actually make it now. We do play against the boss, okay. I guess that makes sense. We dropped a bit, so we're going to be playing against him back and forth. Hopefully we have just enough to sneak by him. It's very, very close. And if we don't make it by, I'm guessing we could be really cheap and just submit again, because this is within a small enough variance that we might just get lucky. And with 100%, okay. Yeah, we're up there now, so we should be good. And so today what we've did is we've completely optimized an algorithm. Instead of finding the defect, iterators. Iterators. You made a comment about iterators. I do want to clean up the code. I tried making iterators once. Right there, okay. Copy. And that was for closest tanker. I'm going to put a comment here. Min by something. So I guess there's a max by as well. I'm just going to put it in the code, and then I copy this out. But thank you very much. That is exactly why I want to actually do this. Is a lot of the stuff is really people looking at it. This is not, I'm hoping, the way Rust actually looks. It's the way my Rust looks. But I really want to get the stuff like these idioms like min by and stuff, because this is really annoying to write. And we'd have a max by for score, which simplified as well too. Where are we on the leaderboard? I think we should be fine. We've got a good enough lead. We play a lot of battles though. It's just so high. Okay, and so what was the other comment? So the edA-qa says we're going to have to do a different approach. What I suggest is we take the simpler one, the CSB Clash. What was it called again? Thank you very much. We won. Feel free to cheer. Say, yay, we made it. Unless we drop too far. But I'm going to have to definitely get into the other approaches to solving the game. I'm going to look up more. And I don't actually want to look at any potential answers. I'm going to look up generic things. It's actually kind of fun to figure this out on my own, but we'll take a simpler one. The problem I have with this one is it's really hard to sort of see. The screen is crazy. There's so much happening. It's way as full collision. Yeah, I'm generally okay with the physics. It's just, but there was one with another racing where there was one I saw, an easier one where you just go across a bridge, and I wanted to do that one first because I think it's the one I can do. It's a pathfinding one, and I'm not sure which one to do. I'm just wondering how much I actually have to go into the AI algorithms for them. I'm okay with scoring and everything. I'm okay with the physics, and again, you see, I'm not okay with parsing data. And yeah, I don't remember I saw it. There's like little holes in the bridge. You're on a bike. It was on Coding Game, and you just have to go up and down the rows, and you can jump over some of the holes. And I don't know if that was in Compete or one of the levels or what it was. I really don't know what it was anymore, but I saw it here, and I was intending to do it, and I could never find it again. And our leaderboard, we're looking just fine, I think. We're high enough above there, so we should be fine. We'll advance. Oh, that's not a multiplayer one. No, it's not multiplayer. But it was an oh, maybe it was an optimization one. I think it was just an optimization one. Are the optimization ones any fun? Or are the multiplayer ones more fun? I mean, I don't want to just do AI. I think there's some basics we have to learn here as well. And what's this thing here say? We'll be promoted to the Silver League soon. That's good. Yeah, I don't know where it was anymore. Somewhere. I don't know. The bridge. Maybe that was it. The bridge. How do we get to the bridge? Am I done here? I think I'm done here. I think we won. Just a second. We copied this all out, didn't we? Yes. Is it really in training? Hard, the bridge? Ah, yeah, maybe that's what I saw. But that's a practice one then. And so maybe that's why I never got back to it, because I was looking for the compete ones. But the Radical Russa is saying Clash, no, the Coder Strikes Back. I can do neural networks if network means like up to like 4 or 5 neurons. That's about all I can do. Genetic algorithm. Oh, wonderful. Is there like an easier one to start on? Because I still don't have the Rust stuff done here. Which is that in the bot programming? I do want a multiplayer one. Tron. Yeah. Flood filling. Ah, this one looks good. I think we'll try this one next, because I really need. I think I can actually do these things eventually, but I really need to do something that gets me into it, because I'm still getting hung up by the Rust. I can't quickly enough maneuver through my code in Rust to actually learn a new algorithm at the same time. I need to sort of use existing algorithms. Flood fill and pathfinding, I've written games that use that before. And so I've written tutorials on them before, so I should be able to do it. I haven't done it in a long time, but that challenges my Rust too, because that gives me an open set. I can deal with open sets, and I can do the heuristics there. But to try and do this with the genetic algorithms at the same time, because I've not done much with genetic algorithms, it's going to be too much. So I think I will stick with this next. And we're at the Silver League in that one. I think that's all I'm going to do for tonight. I don't think I'm going to do any more right now. So I should be able to, I don't know if I'm going to be back tomorrow or sometime next week again. I had fun doing that. I'm going to probably look up a bit more on some of the algorithms. I'm going to follow up with that code, maybe do some of it offline, because some of the stuff I have to look up. But then we could do Tron next time. Let's plan to do Tron whenever I come back next. Okay, so we finally, this is what I was just waiting for. We got it to the Silver League. And I think we're good enough with that. And that's where I'm going to call it a night this time. I thank you all very much for watching. Hopefully tomorrow I'll get a chance to come on, but I might not be here quite late. So if I'm not home early enough, I won't do it. If I'm home in time, I will do it. Otherwise, I might have to wait till Thursday of next week. If I get a chance, maybe Wednesday. But on Monday will be the Fuse show. I'll be doing animations and apps. Thanks to US Uberland. And Wednesday will be animation and apps, and we'll keep. So the animation is also fun if you like animation. Instead of us challenging it, I write my own animation in Fuse. We can see that, and then of course next Friday will be the Leaf one, but definitely at the latest next Thursday. But hopefully tomorrow I'll get on to at least start the basics of Tron, or clean up the code. And thank you very much for watching. Thank you for the comments. Thank you for coming out, and please subscribe, join, follow Twitter, all those things, or on YouTube if you want. Thank you very much, and have a good evening.